Okay, so here we are on a game board at 3.2F. We're going to back up a little bit, and I'm going to remind you that we are in Unit 1, Lesson 5 in your textbook. So if you're looking for this on your own in your textbook, that's what you would look for. And we're going to look at how do gases and plasmas change state. So back to this slide. This is going to be a slide that you should be able to explain every little piece of it. So it's kind of like a snapshot of your understanding of this part of the unit. So we're going to be talking about plasmas and liquids. Remember that plasma is a state of matter when added heat energy causes gas particles to lose electrons. So it's kind of like an ionized gas. You have gas that has electrons that are bouncing around that causes it to have a little bit of a charge. Remember from elementary school that an electron is a particle around the nucleus of an atom that has a negative charge. It is very small compared to the rest of the atom. So places where we can find plasma: flames, aurora borealis, lightning, and in the sun. So we're going to watch this short video on plasma, the most common phase of matter in the universe. It might be a good idea to write down a few things in your textbook guided notes as you go along. Maybe something you find interesting, or maybe they explain the definition of plasma in a better way to help you remember it for your test.
I don't know about you, but if I was on a ship and I saw a glowing sphere of light suddenly floating around the top of the mast, I would be, I think this is the proper term for it, freaked out. But for centuries, sailors saw that all the time, and they thought the mysterious blue glow was a good omen because they associated it with the end of a storm. They called it St. Elmo's fire, after St. Erasmus, the patron saint of sailors. But we now know that it's a natural phenomenon. When the pointed end of a ship's mast interacts with the heavily charged air, like during a storm, it can create a ball of plasma. Plasma is the fourth state of matter, after solid, liquid, and gas. And even though it makes up 99% of the visible universe, we didn't know plasma was a thing until the late 19th century. In 1879, Sir William Crookes, a British chemist, first discovered that he could make what he called radiant matter using a glass container with 2 electrodes in it, which he used to ionize the gas inside. This matter was later called plasma by American chemist Irving Langmuir in 1928 because he decided that it looked like blood plasma. Plasma is like a gas, but instead of containing neutral atoms or molecules, it's made of ions and electrons. So to create plasma, all you have to do is create conditions in which electrons get knocked off the particles in a gas. Sometimes this happens because the gas is hot. The extra energy knocks electrons out of their places, ionizing the gas. Other times, a powerful electric current can eject electrons from gas particles, turning that gas into plasma. But even though plasma essentially comes from gas, it acquires so many special properties that it's considered an entirely different state of matter. Normally, for example, gas isn't all that good at conducting electricity. Actually, it's often used as an insulator. But in plasma, there are so many detached electrons floating around, it becomes incredibly conductive. This conductivity shows up in lightning, for example. When a powerful current forms between 2 highly charged areas in the atmosphere, it passes through a long, skinny column of air, heating it to 5 times the temperature of the surface of the sun. Lightning is actually a trail of plasma. And since electric fields and magnetic fields are both the result of the same force, electromagnetism, plasma also turns out to be very responsive to magnetic fields. Researchers often use this when they're trying to control the stuff, to study it. But we also use plasma all the time in our everyday lives, like in fluorescent lights. When you turn on a fluorescent light, an electric current ionizes the gas in the bulb, usually argon with a little mercury, and it becomes plasma and interacts with a compound called phosphor to create light. So sure, you'll find plasma in all kinds of places on Earth, but in space, the stuff is everywhere. Stars, for example, are just giant balls of plasma. The tremendous heat generated by their fusion reactions has the same effect on atoms of gas as found in a Crookes tube or a fluorescent bulb, only much more so. And there's plasma between stars too, even between galaxies. We normally think about the space between stars and galaxies as a vacuum, and a lot of it essentially is, but there are a lot of places that have quite a lot of matter. It's just spread out over light years of empty space. And that too is plasma, pockets of gas that have been superheated into clouds of ions and electrons. Cosmologists think that up to 50% of the normal matter in the universe is strewn around between galaxies in this form, known as the intergalactic medium. So you don't have to be an old-timey sailor to witness the fourth state of matter. It's right over your head in those fluorescent lights and outside your window the next time a thunderstorm comes, and, well, all over the universe. Thanks for watching this episode of SciShow, especially to our subbable subscribers who keep us energized. See what I did there? To learn how you can support us, just go to subbable.com to learn more, and don't forget to go to youtube.com/scishow and subscribe.
Okay, so on this page, page 96, you have an explained question, number 17, and it says, why does air in the plasma state conduct electric current, but air in the gas state does not? And he explained that in the video, so if you need to, you can back up and watch that part again. Make sure to use vocabulary words and make sure to write more than just 1 or 2 words. The next question is an identify question, and it says, in the box below each picture, which is right here, write the state of the substance shown. And hopefully that's going to be a pretty easy one for you to figure out. Here we are on page 97, and you have a design question. And it says, if you were an engineer designing a plasma display device, would you select a gas for your design that formed a plasma at high temperatures or low temperatures? Explain your reasoning. You don't have to do this with a partner, and actually, we can omit number 17 if you want to. So I put this up for you guys in the resources. These big Tesla machines are really quite interesting, and there's several of them around the world. This one is in Alameda, California. It's probably not the largest anymore since this video was in 2019. I'm going to play a little bit of it for you just for fun, but you can watch the rest of it. It's posted in the resources, I think, for Thursday, September the 7th. There you go.